We created a car that works by the hand gestures to help people who are disabled and they can't hold the steering wheel. So the car, mainly you control the car by these 4 sensors. One of them is responsible for the front instruction and one of them for the back, left and right. They are assigned and they are installed in a way that they form a diamond, so that when you point at this sensor, you go front, left, right, and back. This is the sensor. When I put my hand on the sensor like this, the charge will go front.
Okay, we have 4 sensors. One for the front, one for the back, one for the right, and one for the left. And each sensor has 3 pins, one for the VCC, one for the ground, and one for the output, which are connecting to the Altera. And all the sensors are connecting parallel to each other, and they are active low, and they are connected to the Altera to have the same voltage, which is 5 volt.
Here we have the H bridge, which controls the wheels and the motors of the car. Here we have the channel for motor A, channel for motor B, which will be explained later by my colleague Hazem. And here for the voltage and the ground connected to a 9-volt battery. The H bridge takes its input from the Altera, connected through this wire, onto this bridge, onto this breadboard. The inputs of the H bridge are the enable for motor A and 2 other inputs for the control of the direction, where one is high and the other is low. And to make the car go backwards, we just have to inverse the order of the inputs. The other 3 are the enable for the B and 2 inputs for the motor B to control its direction.
Here the wiring is so simple. We have 4 motors for 4 wheels. Each 2 motors, we connected them together. One of them we took the positive and the negative, and we connected them with motor A in the H bridge, and the other one with motor B in the same H bridge. And we have here, we close the circuit, so we connected a wire from the positive here to the positive of the other motor, and the negative of the same motor to the negative of the other motor. So those 2 motors are connected together, and those 2 motors are connected together.
Okay, so we made the program, basically a Verilog module that uses 4 inputs corresponding to front, back, right and left, corresponding to those sensors. And we use the combination of the 4 to make cases. And according to these cases, we generate outputs. The outputs we have in the code is 2 registers. Each of them is 3 bits. The length of it is 3 bits. And in the pin planner program of the Verilog module, every bit is going to correspond to an output wire. So when we use the cases from front, back, left, and right, the combination of them, we can give an output enable to enable motor A, and also enable to enable motor B, and also by giving different outputs, 0s and 1s, we can generate opposite polarities of the motors to make the car go forwards and backwards. So that's basically the logic behind the code.
So as my colleagues have said, we have 4 sensors that should be connected to the Altera, and that should be connected, and the output should be connected to the car. Every sensor has 3 wires, 3 wires should be connected to the Altera. One for the VCC, one for the ground, and one for the VCC, one for the ground. One is the output that should go to the car. And the H bridge is connected also to this breadboard that connects it to the Altera. So to make the output from the sensor go to the car according to the code written, and what is coming is the execution of how the car works.
بس على نادين اتفرج